All right, ready to start? So if you guys look at the checklist that I've given you for organic chemistry, like I said, the first bit is all a list of everything that we are covering. And then the back bit, I do have kind of an outline of the achieve merit and excellence criteria. So I'll first look at this to kind of get a reference point of what we're doing today and why. So we are looking at number 1 off of that concept list, and that's going to be looking at all the various function groups they could ask you, knowing how to identify the function groups, knowing how to name them, and knowing how to draw them. And what I've also provided is a list of all the function groups that we are covering. All of these we have covered in spec, so this should be familiar to you. The only one that would be brand new would be these esters, which I'm teaching you how to name today. But basically, all of these things you should have ticked off as we have already covered this in class. And I'll do this one today. I've also provided you guys columns, so that way you can check that you've revised it for the mock exam and for the end of year exam, and if you feel like you've mastered the concept. This is basically the foundational stuff for organic chemistry. And if you struggle with the naming and drawing, it's only going to get harder. So that's going to be a good indicator whether or not you want to do this exam or not. Like I've been saying over and over and over again, organic chemistry is easier to get the excellence on because there's not a whole lot of writing. So long as you understand the concepts, you'll be fine. The problem with organic chemistry is that it's very hard to get an achieved on because you need quite a bit of knowledge to be able to attempt the questions, and you can't rope learn it. So just keep that in mind when you're making your decisions. Thermochemistry, like I've been saying, is easier to get the achieved on because you can rope learn that material and there's nice categories of questions. The downside is that thermo, I would say, is harder to get an excellence on because there is quite a bit of writing that needs to be done, and it does require both writing and math skills. So next week, we'll have a decision on which of the two you guys want to sit. I would suggest only sitting one of the two exams because in order to get the 14 credits, you need to pass one of the chemistry exams. The only real exception are those that are applying for Otago for their medical school because they do require 18 credits in one of the specialized subjects for science, and you might have chosen that chemistry is your science subject that you want to do that in. What else did I want to say? If you are needing more credits, I would rather you take the Earth and Space Science internals instead. It won't count towards your chemistry UE, but it will give you credits overall to level 3. So if that's something you guys want to do, I'm happy to enroll you in those standards, and you can just work on them in your own time. Cool? Makes sense? All right. The other thing I want to point out is the assessment requirements. For the achieve merit and excellence, we are basically just tackling this here, which is an achieve point, the naming and the drawing of the organic compounds. So lots of work is going into this just for an achieve requirement, unfortunately. Every so often, these questions might be worth merit, and it's basically you get the whole table correct. Are we okay with that so far? Cool. Okay. The next thing I want to point out to you guys is the audit of questions. This I took off of No Brain Too Small, and I think it's a great resource because it shows you what questions have come up and what years they have come up in. Really useful so you guys can get an idea of how likely a question is going to come up or not. We can see here that I'm looking at the first two. We're going to draw structural information given the systematic name rules, and we're also going to be identifying function groups. So those two we are covering today out of our content list. If you guys are looking for this later, this is going to be lesson number, I think, 8. Is it lesson 8 or 7 on Google Classroom? I can't remember. We'll double check. As you can see, they have asked this question every single year, so we need to cover this. The identifying of the function groups, they don't really ask that often. But like when it comes to naming, you're going to be doing that anyway. Cool. All right. So let's look at those collated questions for the naming and drawing. I figured that would be a good way to start, simply because, what was my thought process? There's not really a whole lot of like teaching per se. It's just, do you remember the rules that we've talked about? If you guys remember in spec, I didn't require you guys to name things, but in the exam you are. All right. I'll go through the 2021 first, and then if you guys feel like you still need some more examples, I can go and do I'll do 2021, and if we want, we can do 2020. All right. Do you guys want me to first start with the name to drawing because it's easier? Yeah. Whichever is easier. Okay. So naming wise, remember what you're looking for is the parent chain and how many carbons there are. I can see that this one has butane. So that tells me 4 carbons are going to be in this carbon chain. It's an oic acid, so that tells me it's a carboxylic acid. Oic acid tells me it's carboxylic acid. And the last thing it tells me is that you have a branch coming off of carbon number 2, which is a methyl, and a methyl would be only 1 carbon. So what I should draw in this case is 1, 2, 3, 4 carbons. Next thing I like to do is put in my functional group, which is my carboxylic acid. It can either be on the first carbon or the last carbon. Doesn't matter which one because we're going to label that as carbon number 1. So I'm going to put it, I don't know why I like to put it on the right-hand side. So that's C double bond O. That decides that this is carbon number 1. So 1, 2, 3, 4. The methyl's on carbon number 2. So 1, 2. I should draw a methyl over here. That is CH3. And then the last thing I will do is put in my carbons. Remember, put in my hydrogens. Remember to count them properly. Each carbon can have 4 bonds. Don't give carbon more than 4 or less than 4. So since this carbon has 1 carbon attached to it, it only needs 3. This carbon here has 1, 2 things attached to it, so it only needs 2. This one here has 1, 2, 3 carbons attached to it, so that only needs 1. And this carbon here has 1, 2, 3, 4. So doesn't need any hydrogens on there. Are we good? All right. Next one that I'll do is this one, the 3-bromopentanol chloride. So again, we look to see where our parent chain is to give us a number for carbons, and that's going to be 5. I see from the ending here, the OLY and chloride tells me it's an acid chloride. And then it also tells me that I have a bromine on carbon number 3. So if I draw my 5 carbons, 1, 2, 3, 4, 5. Again, I can decide to either put it on the first or the last carbon. Doesn't matter which one, because that's just going to be the deciding factor for one. I don't know why I like things to the right. So an acid chloride is a double bonded oxygen and a Cl. Cool. All right, next thing is I'm going to add my bromine, and that's on carbon number 3. This is carbon number 1, 2, and then 3. So what we have to be mindful of when you guys are naming and drawing is that you can only number the carbon chain once. You can't number it twice. And then last thing is I added my hydrogens. So that guy needs 3, that guy needs 2, that guy only needs 1, that guy needs 2, and that guy doesn't need any. Cool. All right, let's go in the other direction now, which is our drawing to naming. Sorry, yeah, drawing to naming. So we have this guy over here. First thing I'm going to do, I'm going to actually change colors. That way we can see which is which. Is I'm going to figure out functional group, and I'm going to figure out number of carbons. So I see that there's 1, 2, 3, 4, 5, 6. There are 6 carbons. If we weren't sure which one was 6, we can use our handy dandy notes. 1, 2, 3, 4, 5, 6, 7, 8. So hex is what I'm going to be using for my parent chain. The next thing I'm going to double check is my functional group, and I see that I have a C double bond O. You guys should hopefully remember your functional groups from spec. That's a carbonyl. and that carbonyl is not attached to carbon number 1. So I'm dealing with a ketone in this case. Are we good so far? All right, if we want to double check, we can go through our notes and try to find our ketone rules. So we are looking for, that's an aldehyde, ketones. So ketones are named by replacing the ANE ending with an ANONE, 1 basically. Be mindful that we do need to state the position of this carbonyl because it can be on different carbons. The aldehydes we don't need to do that with because it can only be on carbon 1. So if I was to go to name this, it would be hex and then we are going to give it the lowest number possible. So if I number in this direction, it would be 1, 2, 3. If I numbered in that direction, it'd be 1, 2, 3, 4. So 3 would be the lower number. So hex N 3 on. And that's how I named that guy. Are we good so far? Questions, concerns, comments? All right. Do you guys want to take a little break and do some practice naming? Do you guys want me to go through and do this last one? This one's the ester, which is the new stuff. Do you want me to do it now? Okay. Cool. Let me explain esters to you and grab another piece of paper. Esters are a little bit more complicated, and there's a reason why I kept it out in the initial teaching. All right, I'm just going to draw this on a new piece of paper so that way we can actually break it apart. So with the ester molecule, it is CH3, CH2, CH2, C double bond O. Then there's a single bonded oxygen that's now linking it to another carbon chain. Are we okay so far? All right. So this here is my ester functional group. Now, in order to make an ester, we're actually combining 2 different organic molecules together to do that. We are combining a carboxylic acid plus an alcohol to do that. Are we okay so far with that? All right. So we are going to think about this as 2 separate molecules that we then attach together. So the first thing that we are looking at is we have this carbon chain here that includes the carbonyl, and we have this carbon chain here that includes the single bonded oxygen. So there's 2 organic molecules in there. This one here, the carb is from the carboxylic acid. It would have come from CH3, CH2, CH2, C double bond O, and it would have originally been like this, which is 1, 2, 3, 4, so butanoic acid. Are we happy with how I see that? All right, this guy over here was originally OH, CH3, which is my alcohol. That one is methanol. No, did I spell it right? No, I'm right. Yeah, methanol. No? Oh. Are we okay with that so far? So I've just broken up my organic molecule so that way I know how to then name it later. All right, the way we name organic molecules is we treat the alcohol as a branch, and then we treat the carboxylic acid as the parent chain. So we would call this methyl butanoate. So the O8 is the ending that we use for esters. Cool. So that is the alcohol component. So unfortunately, it does that little switch. And that is my carboxylic acid component. If I draw the molecule in reverse, it's still the same one. So let's say I did, if I did CH3O, C double bond O, CH2, CH2, CH3. If I had this molecule written in reverse, it's still the same organic molecule, because when I break it up, this is the alcohol component, and this is the carboxylic acid component. So it's still the same molecule. So you can draw it either way, and it's still correct. The thing that you have to double check is make sure you have the right number of carbons to each one. The other thing to keep in mind is don't forget to include that carbon in your counting. A lot of people miss it out because they just don't see it. Do you want me to show you another one that would then be different? All right. If I was to swap this around and I was going to have, I'll write it on the same page because then you can see it as a comparison. So if I was to swap this around and I was going to do butane, let me double check that I have that right. Is it butane? I think it's pentane. Pentane. One, two, three, four. This one then is over here as the methyl. Yeah, so I don't name it as a 5-carbon chain. I split it into 2. That's the complicated thing with esters. All right, let's say I was doing butyl methanoate. I just want to show you guys what that would look like. So if that was the organic compound that was given to me, this is telling me the alcohol component, and the ending bit tells me the carboxylic acid component. Are you okay with that so far? All right. Again, either way that you guys want to draw it will be marked as correct. So we can draw the alcohol bit first, and it would be 1, 2, 3, 4. And then the carboxylic acid component would be the C double bond O, OH. So that is considered one way to write it. If you flipped it the other way around and did that instead, both of these are the same molecule. So I want you guys just to be mindful of that when you see it, not to get thrown off. The main thing you're looking for is where the carbonyl is. That should not be, should be CH3. Sorry, my mistake there. So busy writing carboxylic acids. Sorry, CH2. Okay. So you see how this molecule is different from this molecule, even though they both have the same number of carbons. I've just flipped the the alcohol and the carboxylic acid. So you see we still have the ester component here, but the chain of the alcohol is the 4-carbon instead of the 1-carbon. And then this one here, the carboxylic acid component is only 1 carbon, whereas this one was 4. So they both look the same, but they're 2 different molecules. So you got to be really mindful of where that carbonyl is. Cool. Questions, concerns, comments? All right, you guys ready to try this on your own? Now you guys have maybe have a decision on whether or not you want to do organic chemistry. All right, so the plan for this lesson is basically to give you guys a chance to practice and study this. So just work through these collated questions. I'm happy to go and check answers, but the answers are on No Brain Too Small, so you can check it there as well. And I'm happy to go over them if you guys are kind of stuck on some of them, especially the esters. Cool. All right, give it a shot.